Hi you folks, this is Tim Grutman. This time I'll show you an example in MonoGame. We'll create a virtual controller. So first let's clone the Ouya SDK examples. Okay, Ouya-SDK-examples. Alright, clone that. So if I hop into the Ouya SDK examples, a new folder for MonoGame. Okay, and I need an instance of Visual Studio. Okay, so here we are in Visual Studio 2012. I can do a new project. I want to do it at the path we were just at. Alright, and this will be a virtual controller. Okay, and we're going to do a MonoGame for Ouya project. Okay, and take a look at where it created it. Virtual controller off MonoGame. That's exactly how I wanted to set it up. Great. Okay, and there's an update to Xmarion. I'll have a video on setup for how to handle this stuff, but we'll just ignore that for now. Okay, and now we have the basics for an example. So if I hit Control F5, okay, well first, the default is usually prompt for device, and then if your Ouya is connected directly from Visual Studio, we can just hit Control F5. It'll build, okay, and then our first failure. Okay, so this has to do with, in the references, this Ouya console API that's supplied with the current install is old. Might have been what was related to that update, so we just delete that. And I had rebuilt it from source, and I'll just add the new guy here. Okay, so we need a new Ouya console API that integrates the 104. So we can pull that right off of GitHub and bring that into Visual Studio. If you take a look in here, they've got a simple project you can build. And I did a build of that. Okay. This is a wrapper around the ODK SDK jar. Alright, I'm going to copy the compiled Ouya console API DLL right into our virtual controller project. Okay. And now we can add the reference. Okay, in a virtual controller we can add the reference to the updated DLL. Hit OK. And build. And now our build succeeds. So now Control F5. Okay, great. So now I'm capturing from the Ouya here, and we get the cornflower blue, and then hello from MonoGame. And let's just drop that down into the visible area. So if we go into the game logic, MonoGame is basically a wrapper around XNA. So if you're familiar with XNA, it uses basically the same API. So let's bring this into like 100 in and 100 down. The app now, and here we go. Hello from MonoGame. So now in our virtual controller example, we want to show some controllers. So the best way to get that is to use Nix controller textures. So in the ODK 104, under samples, Ouya controller test app, resources, drawables, here's all the images that we need to create a virtual controller. So I will just copy these into our project. Everything except for the launcher picture, and yeah, I guess that's it. Okay? And we'll go right into a virtual controller, and I'll make a subfolder here, graphics. Okay, these are the graphics we want to use. Okay. Now, XNA and our graphics. Our graphics are PNG pongs, and XNA works off XNB files. And so you need a way to compile your PNGs into the expected XNB format. Now there's a way like to load from streams, so you can load a PNG, but if you want to be cross-platform, it's better to just build it as an XNB archive. So MonoGame has various tools in its Git repository, and if you clone the Git repository for MonoGame, here we go, you'll find tools, and within tools, MGCB is short for MonoGame Content Builder. And this is another solution file you can build in Visual Studio, and it outputs a tool, the MonoGame Content Builder. And this will let us take our Pong files and compile them down into the XNB files. MGCB it has command line arguments, but it also can take a script file. And maybe I'll show it on the command line. Okay, so if I MonoGame Content Builder, by itself, it takes a response file. So you can put all your config settings into a response file, and it will build the content. So I'm going to do this through a script. Okay, so we have a virtual controller directory, and we have the graphics we want to encode. Okay, now if we go back into our virtual controller folder, I'm going to take this build XNB script. I have a custom script that's just a convenient script that will take the built MonoGame Content Builder executable, and it will use a response file called MonoGame Content Builder response.txt to provide the command line arguments. So when I want to encode the textures, I just double click this command script and it will build the XMB files. Now we need the script, the response file, to provide the arguments. So here we go. Okay, so this is basically the example script, but I have modified it to include my own textures. So I'll change this to be graphics to match the path that we used. Okay, cool. So the important things are the settings, our platform is Android, the profile is a Reach profile, and the output directory is going to be the content directory, which our XNA app will be able to pull in from. And then it's going to encode all these PNG files as XNB. Alright, so I saved it, and I'll run the build script. And if I do one little change here, if I add a pause, when I run it, you'll be able to see what happened. Okay, so we ran our script with response args, and it took all the PNGs and created the XNB files and placed them in our virtual controller Now this is the source where they came from, and it placed it into assets, content, graphics. Okay. So now if we look at our asset content, graphics, there are all the encoded X and B files for our graphics. And these are the textures that we want to display. Great. Okay, now, alright, back in the code, we're going to need a class to create a virtual controller that will handle displaying and positioning the controller items. Alright, so the next step we're going to do is we're going to add a new item. It'll be a class, and this will be our virtual controller sprite. Okay. And now we're into XNA land. So that we're going to need each virtual controller to map to an actual controller. So to do that, we'll identify each controller with a player index. And set a default. Okay, we also need the XNA framework. Okay, just organize this a little bit. Okay, and with the XNA framework, now we can use a player index. And this is the controller index. Okay, now because it's a sprite, we also need a public vector2 for positioning the sprite. And we'll set it to the default of vector3, vector2 0, the position of the sprite. Okay. Now we need some texture references so we can display, the sprite can display a texture. So that would be texture 2D, and that's part of the graphics framework. Okay. So a virtual controller is going to need all the buttons, the D-pads, the controller, and the sticks. So here's where we label all the buttons. I have a habit of always setting defaults. And these are going to be very similar to, if I show all files for a minute, all these file names here. And since I've already labeled them, here we go. So button A is the A button on the controller. Same with O, U, and Y. So the O, U, Y, A buttons for the Ouya. There's the actual controller background of the virtual controller to show the buttons on. Then of course we need the D-pad buttons. And then the left bumper, the right triggers, and then there's the left stick and right stick. And because those are going to move, we need to separate those out to be in inactive and active state. And for a minute, if we look at the textures we're working with, in the virtual controller, graphics, here we go. So here's the textures that we're putting together. So the way it's going to work is we have the background controller. And then as you push the different buttons, okay, so that would be like the A button, it's going to highlight and draw that blue over the virtual controller so we can see that the button is pressed. Same thing with the sticks, and then, but with the sticks, there's coordinates, and so we can move the that little stick around, and it'll fit on top of this controller and move in the little circle. Okay, so that's why we need all these texture references. And then another thing that always happens with when you're using an axis, you want a dead zone so that you don't want it to always like light up when it's around the origin of the stick. So we'll just use 025 for now. And we'll need a few functions for our virtual sprite class. So we're going to have an initialize method. And all this initialize method is going to do is like, it'll set the texture references. Okay, and then we'll need a draw method to draw the virtual, well, it's going to draw the sprite of the virtual controller. Okay. Alright, so now we have a virtual controller. It's going to have some textures, but how do we load these textures? So turn off show all files. Well, maybe turn them back on. Go into our assets, content, and make sure it includes these graphics. Good. Okay, we need to load these graphics. So that goes back to the game. So we have our game loop, and it's going to be useful to have a list of these guys. So let's add using system collections generic. Alright, and then that'll allow us to have a list of virtual controller sprites. Okay. And then for the example, we'll add our initialization logic here. Great. Alright, so we need to have 4 virtual controllers. So I'll just do a for loop when the index is less than 4, plus index. Okay, great. And maybe this could be configurable too. So maybe add a int const int max controllers. Set that to 4. This can be private too. Okay. Now we can construct our virtual controllers. Virtual controller sprite equals the new one. Controller dot initialize, and add it to our controller list. Okay. So now that it's initialized, we also need to draw the controllers. So in our draw event, so it begins doing the drawing, it draws hello from MonoGame, and we'll have to draw our controller sprites. So we can do a for each virtual controller sprite controller in the controller list. And then just make sure mcontroller draw something. Alright, let's look at the controller again. It has a draw. Oh, controller draw and pass it the sprite batch. Great. Alright, now if it could draw something, it would. And just compile, it still compiles. Okay, now has to do some other stuff, like we need to load the textures for the controller so it has something to draw. Now, that's why we have this load content. So we need to load the textures. So, let's again loop through each controller. Okay, and we want to initialize each controller while also passing it the content. So, controller initialize. Alright, and if we go to the initialize method, the only thing we really need to pass to the controller is these textures. So, I guess texture 2D texture. Alright, and then that's going to require that we pass a texture. So we can pass it content, load, it's going to load a texture 2D, and we're going to call graphics, because it's assets, content, graphics, and then cutter. So cutter was the one where it's a cutout of the controller without any of the buttons. Okay. We'll just, for testing, before we launch everything, we'll just show it draw one of these guys. Alright, so initialize doesn't take 0 arguments. Oh, okay. We'll initialize it while we're loading the content. Okay. Cool. Alright, so we've loaded a texture, but we're going to need to have to position the controller. So, let's calculate where to display this controller. I'll use a vector2 position. It'll equal something. And then I can just say controller.position equals that position. And it will position it wherever I want. Okay. So now let's pick where it shows up. So we need a vector2. And I have pre-calculated what I wanted to use here. But basically I have the point using some math here. So, okay, so graphics device, viewport, title, safe area. There's a safe area within the, the overscan area for graphics. So we want to start there, and then we're going to display for the controllers. So we just have to fit those in the default resolution, which is 1920 by 1080. So with this math here, it'll just fit nicely and space them out a little bit so they have a little padding between each controller. So we offset it to a little bit to the right, and then each controller we're going to make about 350 wide. And that's enough space to show all four in a row. Okay, so now we have a controller position, and we're invoking the draw calls. That's pretty much it for the game, but now the virtual controller has to actually draw something. And I want to write a helper function here, which is, we'll have another draw function. It will take the sprite batch as usual, and it will also take a texture to display. I'm just wrapping this because I know I'll eventually have to do a if the texture is not null, and then we go and draw the texture. Then I don't have to check the texture repeatedly to see if each one's null if I'm going to show all these other textures. Okay, so we do the null check, and then sprite batch, draw the texture, pass it the texture to draw, pass it the position to draw. Okay, well that would actually be useful to pass in. So let's give it a vector to position. That way we don't draw everything in the same spot. So we have a position to draw, null, a color, I'll just make it white, I don't want to change the color. Don't rotate it. No need to pivot, just set it on the origin. We don't need to change the scale. We don't need any sprite effects. And don't worry about depth. Alright, and then maybe another convenience function that if we decide not to change the position, it will just draw that texture, well, a sprite batch. It'll draw the texture at the position of the virtual controller. Okay, now there's the actual draw that's being called from the game logic, and we can tell it to draw the sprite batch and pass it a texture. And I'll just have it draw the controller for now. Okay, so it'll always draw the controller at the default position. Okay, compile that, and at this point, just double check, initialize. Okay, let's make sure the controller is set. So we'll set the controller equal to the texture for now. Okay, so I'm going to run it, and if I switch over to the game capture, you can see that we just drew 4 controllers. Right now I hit all the buttons and nothing happens because we need to get the access values and button values to actually highlight these different states. But first, we need to actually draw everything. So we were initially passing in just the controller texture, but we actually need to initialize with all the different sprites. So let's fill this in with all the textures we want to draw. Okay, because we want to draw the buttons, the controllers, the D-pads, the bumpers, the triggers, the sticks, and I basically mirrored the same order of the X and B files here. Okay, but then we also have to set the references. So make sure when we pass them in that we also set the references to the textures. Alright, but now we need to also, in the game logic, when we load the content, we also need to load the content for all the images. And I have that here too. Okay, so now we load all the textures in this same order here. So to initialize the controller by passing the content, set the references, and now we're ready to draw everything. So let's go to our first draw command. We want to draw something when they push D-pad. Let's start with D-pad. Okay, so there's something in XNA called gamepad state, and we can get the gamepad state from the gamepad. And for convenience, let's just add a method to get the gamepad state. So gamepad state get state. Okay. And that just means we need to get the gamepad state from the gamepad. Okay, and then every controller we marked it with an index, so we need to be able to say, give it the index. And that's the index, the first parameter here, the player index of each controller. And double check the game here. When we initialize each controller, we need to set the index. And actually we can do it in the initialize here. So we set the position. We also want to set the controller index. And I'll just use the index. Okay, and it just needs to cast it to whatever this index is, which is the player index. Okay, and if we look at the definition, 0, 1, 2, 3, we'll cast it to the right index. Because the index is 0 through max controllers, and it will, as long as there's just 4, it will cast the index correctly. And then in our virtual controller sprite, when we go to get the state, it'll use the right index and it will return the gamepad state. Alright, now we want to see if the D-pad is pressed. So once we need to get the state, so gamepad state equals get state. Alright, now if this state, and on the state there's D-pad, and if the down button on the D-pad is pressed, then we want it to highlight. So we'll just call draw. We pass it the sprite batch, and then we pass it the texture to draw. And the texture to draw is going to be D-pad down. Okay, compile it, and let's run it and see if it works. Okay, so now if I hit the D-pad down, it will render that texture sprite, but only for the controller index. So this is controller index 1, controller 1. If I grab another controller, okay, here we go. So on the second controller, if I push down, it highlights down, and on the first controller, if I push down, it highlights down. Great. Now we just have to do this same thing for all the other buttons. So back to the code. So I'll just copy this, and instead of being down, we'll use left. So if the left, and if left is down, draw the D-pad left. Same thing for right, D-pad, and the up D-pad. Okay, so that will handle the D-pads, and we can organize this into a region, D-pads. Okay, the next buttons are the regular OUYA stuff. I think I was actually following this. Never mind. Okay, so now we have another region for the regular buttons. Okay, so we have what the what X and A calls button B actually maps to the button A texture. What X and A calls button A maps to the button O texture. What X and A calls X maps to the U button. What X and A calls Y maps to the button Y. The other guys are more straightforward. What X and A calls left shoulder maps to the left bumper. The same is true for the right shoulder. Maps to the right bumper. And then we get to the axis data. Okay, so there's the triggers. So let's say if state triggers, if the right trigger is greater than, we had a dead zone in there of 0.25. So if it's greater than that 0.25, then we just go and draw the sprite batch right trigger, and that will draw the right trigger when it's over that dead zone. And I'm trying to keep the same order kind of, but okay, actually let's do in region and then region triggers. And then we can have, okay, if it's the left trigger, okay, so that handles the triggers and buttons. Now we have the sticks. So the sticks are axes and buttons. So it starts out like usual. If the button state for the left stick is pressed, then we want to highlight. But it's a little tricky here. So we want to offset from the position because, okay, so the stick is, we want it to move. And we can use the axis value. It's a left stick vector. And by itself, it's going to just range from -1 to +1 on the X and the Y. And that's just going to move it a little bit. We're using a multiple of 4 to move it just enough that it's noticeable and it stays inside the little circle. Okay, but right now it's only highlighting if the button's pressed, so we need to check a couple different things. We want to check it against the dead zone. We want to check the X value of the left stick to see if it's in the dead zone, and we want to do an absolute value so that if it's negative or positive, we're still checking whether it's within the dead zone. And then we also want to check the Y value. Okay, so here we go, where if the left stick is pressed, if the stick is moved a little bit, it's going to draw that blue overlay. Otherwise, it would be empty, so we need to draw an else case. And we have two variables. There's a texture when it's highlighted in blue, when the left stick is active, and then we have a inactive texture when it's just plain gray. It's the same calculation. Start from the virtual controller position, and then just offset it by the axis value of the left stick, and it'll just offset a little bit. And then we'll do the same thing for the right sticks. the right stick accesses for X and Y, and if the right stick is pressed, we show the active right stick image or inactive. If it's not pressed and it's at the origin within the dead zone. Alright, at this point we can run and see what happens. It's going to run right from Visual Studio. I mean, how awesome is that? With the evaluation version of Xmarion. Okay, so here we go. I'm going to hit some buttons. And now the lights highlight. So I see triggers. I see bumpers. I can push on the sticks. And they highlight, and I can move the sticks. And D-pads are right. And that's for controller 1. And let's see, controller 2. Sticks move, sticks tap. D-pad works. Buttons work, triggers work, bumpers work. Great. Alright, so I hope you have a starting point now. With this example, you can hook up your controllers, you can display textures, all in MonoGame. And you can use Visual Studio to publish directly to your Ouya and make games with MonoGame on the Ouya. Alright, thanks for watching.